Let me ask you a question. This side, as usual, you have the intensity of X-ray plotted, and this side you have wavelength. Let's suppose you have this is a kind of rough sketch which has been given to you for two different targets at two different potentials. For two different targets at two different potentials. What is the meaning of this? Say first plot is for target 1 जिस पे इलेक्ट्रॉन की बॉम्बार्डिंग पोटेंशियल V1 हो सकती है, एंड सेकेंड जो है वो टारगेट 2 का है जिस पे की एक्सेलरेटिंग पोटेंशियल मे बी V2 है. नाउ यू हैव बीन गिवन 4 ऑप्शंस. यू हैव टू फाइंड आउट विच वन इज ट्रू. 4 ऑप्शंस में Z1 ग्रेटर देन Z2, V1 ग्रेटर देन V2. सेकेंड ऑप्शन सेज Z1 ग्रेटर देन Z2, V1 less than V2. Third option says Z1, what is Z? Z is the atomic number of the target you have taken. 1 and 2 is the number you are taking for these two graphs. Z1 less than Z2 and V1 greater than V2. And fourth option says Z1 less than Z2, V1 less than V2. ये 4 options आपको दिए गए हैं. And you have to find out which one is true. Now see, for our entire explanation of the X-ray spectra, we had only 2 equations. First, try to see the continuous spectra, based on which you had the relation that charge into potential, that is equal to hc by lambda, isn't it? And this is given to you that lambda is hc by ev. Now, what do you learn from this particular place? You happen to learn that if the wavelength here, now see this particular equation, अगर आप इस equation को देखें तो ये हमारे पूरे ग्राफ में इस particular point से concerned है, isn't it? The minimum wavelength of the X-ray spectra that is being governed by this equation hc by ev. So आप देख सकते हैं कि अगर wavelength कम हो गई है, किसकी वेवलेंथ कम हो गई है? सेकेंड टारगेट की. यू कैन सी हियर, ये सेकेंड टारगेट के लिए है, इसके लिए वेवलेंथ कम है, सो नेचुरली इसके लिए पोटेंशियल जो होगी वो ज्यादा होगी. सो हियर सिंस लैम्डा सेकेंड टारगेट की लेस है कंपेयर टू लैम्डा 1, देयरफॉर यू कैन से V2 मस्ट बी ग्रेटर देन V1. तो पहले तो आप ये देखिए कि जिस भी इक्वेशंस में, जिस भी ऑप्शंस में रादर आपकी ये चीज नहीं है, जैसे ये ऑप्शन है ये गलत हो गया, isn't it? क्योंकि V2 ग्रेटर देन V1 होना चाहिए, या V2 लेस देन V1 दिखाया, यहां पे भी V2 लेस देन V1 दिखाई गई. सो ये दोनों ऑप्शंस आपकी गलत हो गई, ये करेक्ट नहीं है. यू अंडरस्टैंड? नाउ द सेकेंड एस्पेक्ट यू हैव टू जज फ्रॉम दी शार्प जंप्स. यहां पे एक रफ मैनर में आपको शार्प जंप्स दिखाई देंगे, और मे बी इट्स ओनली द K X-ray दैट हैज बीन शोन फॉर बोथ. This is not the L X-ray included, rather it's only the K X-ray which has been shown here. Now the position of this thing that decides the atomic number of the target. इस चीज को देखने के लिए आप मोसेलेज रिलेशन पे जाएं. मोसेलेज रिलेशन को अगर आप देखेंगे तो इट सेज दैट 1 by square root of lambda, this is proportional to the atomic number, maybe Z minus some constant, but here you can say that in a rough manner, lambda and z, they are related like this. What is the meaning of this? Meaning is, अगर k एक्सरे की वेवलेंथ कम है तो इसका मतलब उस टारगेट की z की वैल्यू ज्यादा होगी. फॉर एग्जाम्पल हियर, यहां पे k एक्सरे, ये भी k एक्सरे. फर्स्ट टारगेट की देखिए k एक्सरे की वेवलेंथ कम है, इज़ इट? k एक्सरे की वेवलेंथ कम है, इसीलिए इसके z की वैल्यू क्या होगी? ज्यादा होगी. सो z1 विल बी ग्रेटर देन z2. अगर फर्स्ट टारगेट की लैम्डा की वैल्यू कम है तो उसके z की वैल्यू ज्यादा होगी, एंड देयरफॉर z1 विल बी ग्रेटर देन z2. दिस इज द काइंड ऑफ सीन यू विल बी हैविंग. सो आपको इस ऑप्शन में वो सर्च करना होगा जहां पे z1 ग्रेटर देन z2 होगी. ये ऑप्शन आप देख सकते हैं गलत हो गई, बिकॉज हियर z1 लेस देन z2 दिखाया गया, बट यू हैव z1 मोर देन z2. इसलिए हमारा करेक्ट ऑप्शन जो हुआ वो सेकेंड ऑप्शन करेक्ट हुआ. यू अंडरस्टैंड नाउ? So this is the way you will be handling this kind of conceptual questions, which is based on these two equations. So long as numerical questions are concerned, I have already given you that lambda, that is 12400 upon potential, that is the kind of thing which will be asked to you. And if it is Moseley's relation, then it will be the ratio of the wavelength or frequency coming out from two different targets. That can be asked, based on which you have this particular formula. Now, once you have already produced X-rays, let us now talk about the absorption of X-rays. Let us talk about absorption of X-rays. Imagine that you have a material जिसकी थिकनेस दी है. फॉर एग्जाम्पल, इन केस ऑफ क्लिनिकल एक्सरे, you are firing X-rays, and on the other side the X-rays are coming out after passing through flesh, bones, and finally they are falling on a photographic plate, and the shadow is formed and the structure is formed, isn't it? So here you can say some incident intensity is there. Let us suppose the incident intensity of X-rays, that is I naught, and after passing the target, let us suppose this is coming up, with intensity I, then it has been seen that the intensity variation जो I naught से ये I आ रही है, that is following an exponential decay kind of situation. I is equal to I naught e raised to the power minus mu times d. You understand? What is I? I is the intensity of X-ray once it has passed through the target, and I naught is the intensity of the X-ray when it has entered the target. And let's suppose the thickness of this target is d. Then here, the constant mu which you have defined, this is called absorption coefficient of the material. Isn't it? Absorption coefficient of the material for the X-rays. And of course, this will be following the exponential decay kind of thing. You understand? ये intensity I की variation D के साथ अगर हम show करेंगे तो इसकी exponential decay होगी. Now whatever properties you have for exponential decay, that will suitably be used here, and based on which we will be solving a kind of question also. Now you should understand that this is the kind of thing, or you can say the property of X-ray getting absorbed in different manner by different materials, that can be utilized to check the purity. Let's suppose कोई diamond है, उसकी purity आप check करते हैं, whether cracks are there or not. Then you can pass the X-rays, you can make the diagram of that. In case the cracks are there, that can be deciphered. In case you are passing this X-ray through fractured bone, through normal bone, all the cases will be clearly explained on the photographic plate. For example, on photographic plate, if the X-rays are coming out like this and then falling, naturally if it is passing through the bone, then the intensity of X-ray will be less compared to the X-ray which is coming out after passing through the flesh. इसीलिए जो बोन की पार्ट है वो फोटोग्राफिक प्लेट पे ज्यादा ब्लैकनिंग नहीं कर पाता, व्हाइटिश इमेज आपको दिखाई देती है. बट द एक्सरे विच इज पासिंग थ्रू द फ्लैश दैट इज हैविंग कंसिडरेबल अमाउंट ऑफ इंटेंसिटी, इसीलिए वो फोटोग्राफिक प्लेट की ब्लैकनिंग ज्यादा करता है. एंड दैट वे यू कैन से समटाइम्स व्हेन द क्वेश्चंस आर आस्क्ड, देन यू मस्ट नोट दैट क्लिनिकल एक्सरे इज बेस्ड ऑन the principle of shadow photography. Isn't it? What is clinical X-ray? Clinical X-ray is basically आपने जैसे बाहर से लाइट थ्रू करके उसकी एक शैडो बनाई हुई होती है. On the similar line you can say clinical X-ray is basically shadow photography made by these X-rays. Now, once you have understood the concept of this absorption, let me ask you a question. Let me ask you a question. If the intensity of X-ray becomes 1/3, if the intensity of X-ray becomes 1/3 after passing through 3.5 centimeter of a material, then what will be intensity left over? Then what will be intensity left over after crossing next 7 centimeter of the same material? You understand? This is the kind of question we have posed on you. If the intensity of X-ray becomes 1/3 after passing through 3.5 centimeter of a material, you understand? 3.5 centimeter क्रॉस करने के बाद इसकी इंटेंसिटी 1/3 हो जाती है. Then let's suppose it is crossing the next 7 centimeter. You see the word next 7 centimeter of the same material. तो फिर इंटेंसिटी क्या रह जाएगी? This is what is demanded. Now you see the question posed here. This is of course based on the absorption of X-rays, and here you have seen that it is having the exponential decay property. Now अगर इसकी इंटेंसिटी शुरू में I0 थी और उसके बाद आपको लगता है ऐसा कि इसकी इंटेंसिटी I0/3 हो गई है at 3.5 सेंटीमीटर, 3.5 सेंटीमीटर पे ये I0/3 हो गई है. देन नेक्स्ट 3.5 पे, दैट मीन्स 7 सेंटीमीटर तक पहुंचने पे इसकी इंटेंसिटी 1/3 की भी 1/3 हो जाएगी. दैट मीन्स इट विल बी I0/9. एंड देन नेक्स्ट 3.5 सेंटीमीटर और आप क्रॉस करेंगे, सो दिस विल बी 10.5 सेंटीमीटर. And here if you see the intensity, then again it will be I0/27. This is the kind of property you have so long as exponential decay is concerned. This is not something new to you. Rather, if you see several times we have come across this thing. As if you remember, we had damped oscillation. There also you had this kind of question, say after 100 oscillations, let us suppose the amplitude is becoming 1/3, then what will be the amplitude after next 100, after next 200, next 300? This is kind of question which was posed. So here you see the intensity or the thing which is plotted on y-axis, that keeps getting divided by some number, and this side you keep adding with some number. तो आपको क्वेश्चन में 3.5 की जगह पे I0/3 दिया हुआ था, and the next 7 centimeter is demanded. Next 7 centimeter, that means you have reached here, and the intensity left over, you can see this is I0/27. So your answer will be I0/27 left over, so long as the intensity of X-ray is concerned. So that is all we had for X-rays. You understand? In which we saw the continuous and characteristic spectra and the thing related to the absorption of X-rays. Now if you talk about uses, there are several uses of X-rays. Rather, nowadays if you have to check the purity of a substance, or maybe it's a X-ray photography or detection, diagnosis, in all those areas you have X-rays involved. However, so long as medical applications are concerned, X-rays are gradually getting replaced by MRI techniques, because both of them have several advantage and disadvantage. Let us not discuss that much in detail, but whatever it is based on absorption of X-ray, as you have seen here. Now, as I have promised that there will be more discussion, which you can say the leftover topic, that is electric discharges through gases. Let us talk about that. Let us talk about the electric discharge through gases. And essentially this particular topic explains the discovery of cathode rays, but there are some of the phenomenon that we have to discuss based on the kind of mechanism we have. What I try to explain here is that the first time in the process of discovery of cathode rays, what you had a gas and you have two electrodes, and they are connected to, you can say, high voltage line here. Understand, some gas is here. This is negative end, this is positive end. Now if you are keeping the voltage very high in, say, kilovolts, and gradually you start reducing the pressure of the gas which is inside, at sufficiently low pressure, approximately you can say 0.0 mm of Hg pressure. Understand, pressure आपने इस गैस की काफी लेस कर दी होती है, then you can see some glow is appearing. Maybe यहां से कुछ स्पेस है जिसमें कि एक डार्कनेस होती है, and then you have this region जिसमें आपको एक ग्लो दिखाई देता है. We are trying to understand why this darkness is here and then some glow. If you keep reducing the pressure, then you will find that alternate bright and dark areas are appearing here. And once you are reducing the pressure more, then a time comes when again complete darkness is there in the tube. So now we have to explain that why once you have reduced the pressure, the glowing is appearing and alternate dark and bright patches. Then after that, when you are reducing the pressure to sufficiently low value, then why the complete darkness is present. Now if you try to understand this thing, then remember that जब इसकी प्रेशर बहुत ज्यादा है तो यहां से इलेक्ट्रॉन्स दे आर एसेंशियली कमिंग आउट, बिकॉज यहां पे आपने नेगेटिव वोल्टेज लगाया है, तो कैथोड से इलेक्ट्रॉन्स निकल रही हैं, बट बिकॉज ऑफ द प्रेजेंस ऑफ गैस मॉलिक्यूल्स इन अ लार्ज क्वांटिटी, दीज इलेक्ट्रॉन्स आर नॉट गेटिंग द चांस टू एनर्जाइज, उनमें काइनेटिक एनर्जी नहीं आ रही है, एंड दे आर नॉट इन ए पोजिशन टू एक्साइट द इलेक्ट्रॉन्स ऑफ द गैस, रादर वो कोलाइड करके उनकी एनर्जी खत्म हो जा रही है. सो देर इज नो एक्साइटमेंट और डी एक्साइटमेंट इन द गैस इलेक्ट्रॉन्स, बिकॉज ऑफ विच इट्स ऑल डार्क. But let us suppose the pressure is sufficiently low, then number of molecules which you have here, that is reduced, and now these electrons have the chance to accelerate themselves. और वो कुछ दूर तक जब accelerate करते हैं तब तक ये darkness होगी, और जब acceleration के बाद इनके पास एक sufficient kinetic energy आ जाएगी, then they will be in a position to excite the electrons of the gas. और तब वो जब electrons de-excite होती हैं, then Balmer series light that becomes visible to you. इसीलिए यहां पे ग्लो अपीयर होते हैं. नाउ ऑल्टरनेट एंड ब्राइट एंड डार्क पैचेस मींस दीज इलेक्ट्रॉन्स वेयर एक्साइटेड अप टू दिस प्लेस, यहां तक एक्सेलरेट हो गई, उनमें एनर्जी आ गई. जब उन्होंने नेक्स्ट यहां के कुछ इलेक्ट्रॉन से अपनी हिटिंग कर ली तो इस जगह तक लेट्स सपोज ग्लो आया, बट आफ्टर दैट अगेन दी एनर्जी ऑफ द इलेक्ट्रॉन इज लॉस्ट. फिर ये कुछ रीजन में अपने को एक्सेलरेट जब तक करेंगे तो उनमें ग्लोइंग नहीं होगी. एट दिस लेवल मे बी दे हैव अगेन अचीव दी लार्ज एनर्जी, फिर उस लार्ज एनर्जी के साथ वो गैस पार्टिकल को हिट करेंगे, एंड दिस वे ऑल्टरनेट ब्राइट एंड डार्क पैचेस आर ऑब्जर्व. नाउ द लास्ट पार्ट ऑफ इट इज दैट व्हाई द ट्यूब अगेन बिकम्स कंप्लीटली डार्क व्हेन द प्रेशर इज सफिशिएंटली लो. देन द थिंग इज दैट इफ यू आर कीपिंग दिस प्रेशर वेरी लो, देन द नंबर ऑफ मॉलिक्यूल्स प्रेजेंट हियर that is now very less, and in that case the electrons which are produced here, they are straightway reaching this target. You understand? अगर बीच में गैस मॉलिक्यूल्स बहुत कम होंगी तो चांसेस हैं कि इलेक्ट्रॉन्स बगैर किसी कोलिजन के स्ट्रेट इस पॉजिटिव प्लेट पे पहुंच जाएंगी. एंड नाउ इफ देयर विल नॉट बी एनी कोलिजन विद द गैस पार्टिकल्स, then there will not be any excitement and de-excitement of electrons of gas molecules, and in that case अगर कोई इलेक्ट्रॉन की de-excitement होगी ही नहीं तो फिर वहां से रेडिएशन भी नहीं निकलेंगी, यहां पूरी की पूरी ट्यूब आपकी डार्क होगी. सो दिस एक्सप्लेन्स दैट बिलो दिस प्रेशर व्हाई यू स्टार्टेड हैविंग ग्लो, देन ऑल्टरनेट ब्राइट एंड डार्क ग्लो, एंड एट सफिशिएंटली लो प्रेशर व्हाई द ट्यूब अगेन बिकम्स डार्क. सो दैट हैज बीन एक्सप्लेन्ड विद द हेल्प ऑफ दिस पर्टिकुलर सिचुएशन. So that is all we had in our today's discussion. Now before we move ahead, let me explain what all we discussed in our today's lecture. In today's lecture of X-rays, first we described the Coolidge tube experiment, which you can say this was a formal setup to provide X-rays, in which we saw that X-rays were produced when electrons were bombarded on their target. Then we had X-ray spectra. In X-ray spectra we had continuous spectra. You had a formula explaining that. Then you had characteristic spectra. For which we had Moseley's relation explaining the characteristic spectra. Then we had the discussion on absorption of X-rays, for which we had the formula showing that the absorption of X-rays, that is following exponential decay principle, and at the end we had the discussion on electric discharge through gases. And we had several solved examples. explaining the concepts of the X-ray spectra and the conceptual things related to electric discharge through gases. And that is all we had in our today's lecture, and essentially this particular discussion has ended the chapter of atoms, in which we had the atomic spectra as well as the X-ray spectra explained. And that is all we have for today. Thank you.